Okay, so I've got 100 slides roughly to run through, and I've got 50 minutes to do it, so there's a fair amount of content to move through. Yes. So this talk's broken into two basic parts, a little bit of concepts and understanding security management with regards to the database, and then a lot of implementation and how it relates to Postgres. So with that, dynamic database credentials. I'm Sean Chittenden. I've done a couple things with Postgres, and I currently work as an engineer at HashiCorp. So a lot of what I'm going to be talking about today is going to be a conversation about Vault and how Vault applies to Postgres. So Vault in the ecosystem of HashiCorp tools is the way that we provide secrets management that kind of ties together this workflow story of ours, which is how do you do development, Vagrant, all the way through to production, which is Node, Consul, and Terraform. So we're talking about developing an idea and then getting it into production. How do we do that, and what are some of the challenges that we run into while doing that? So what's the risk assessment of doing something where you have an application that you, the developer, or some developer, as DBAs, some other developer, is going to develop and innovate and then going to push into production? There's a certain amount of risk associated with that. So when we are thinking about that as database administrators, that's largely an operations role. So from an operations perspective, we're primarily concerned with loss aversion. Not exclusively, but that's one of the primary things that we are responsible for in the role of operations. So kind of the quintessential items that you care about for loss aversion are uptime, bit rot, productivity loss. What does that mean, right? Development velocity. You want to be able to take that idea and get from the laptop into production. You want that to be as frictionless as possible. And one of the things that becomes really hard in that kind of world is how do you manage secrets? We'll get into some of the problems that come from secret management as you move to, for instance, containerized applications. And what does that mean as database administrators? So, security is an operations concern, right? Like it or not, it's not InfoSec's problem. Or the developer's problem exclusively. It's an operations problem. So how do you take secrets management and incorporate that into your production story? So loss aversion from the security perspective is, we hear about crypto standards and there's OpenSSL vulnerability of the week, but really some of those crypto vulnerabilities inside of the data center, if you've heard James Mickens' talk about Mossad and not Mossad threat models, nobody really cares about crypto inside of your data center and whether or not something is weak inside of the data center. That's a perceived security vulnerability, not a real security vulnerability. But it is a form of loss aversion that we're kind of interested in, like loss through somebody potentially deciphering encrypted text on the data center network. So what we also care about there is what are we protecting against, right? When we talk about loss aversion, loss compared to what, right? And how, when we talk about some kind of a loss there, what are we willing to lose, right? We're not going to unplug servers and put them into the basement. We need to have some kind of model that says we're willing to accept a certain number of risk, and we're willing to, and we're not willing to accept a different type of risk, right? So what types of things are we not willing to give up, right? We're not willing to give up a leaked secret. So we don't want to see, for instance, usernames and passwords going out the front door. We're also not interested in seeing PII or PCI type data go out the front door. So that's a type of leaked secret. One of the things that we're particularly interested in is guarding the master keys for encrypting and decrypting things. What we don't want to have is and I've seen this before, where you check in usernames and passwords or crypto keys into GitHub in a private repository for somebody to potentially stumble upon or compromise, be able to walk off with. We're also from a risk assessment, we need to figure out who accessed something, right? So if you have a secret, who grabbed or accessed that secret? You don't want that to be a free-for-all, because at that point in time, you have no idea if somebody has compromised you and taken data from your infrastructure. And if somebody's potentially inside of the organization, internal threats versus external threats, how do you prevent an internal threat from accessing something that they shouldn't just because they do have access to the crypto key? How do you know that, or how do you guard and prevent that? And yeah, once you have some form of compromise, how long does it take you to respond, right? You've got a big secrets problem potentially. You don't want to have to deal with secrets management on a human timescale. Rotating usernames and passwords for all of your applications, potentially hundreds or thousands of them, is a very time-intensive task. And so we really don't want to be in a position where we're dealing with them. So from a risk assessment perspective, there's plenty of things that are operational challenges. So as a risk, that's one thing, but if you look at it from there's different perspective, it's an opportunity. So what if, in the case of Vault, we went and took these problems and we said, all right, we're going to go and design a brand new system and try and deal with this in a different way. So we're going to embrace automation, right? We're going to have some kind of a seamless workflow, and we're going to make the system secure by default, so that as somebody consumes these secrets, they are they have the like it says there, the principle of least privilege. You only have access to what it is that you're supposed to have access. You don't have access to the entire database. It would not surprise. Raise of hands here. How many people have their database privileges scoped to the privileges required from the application connecting to the database? Or second part, or part two of this, is how many people have www.dbuser or some equivalent that gives them complete read-write access to all of the tables, and you just assume that the application's doing the right thing, right? Downscoped privileges, or do you give out the generic username, right? And quick raise of hands, like who gives out the generic username to their applications, right? Probably going to be everybody. Everybody's. So, in Postgres, we have many ways of kind of limiting security, but we, don't typically employ them, right? Like this, in particular, this least privilege. There's tons of controls inside of Postgres, and we, as DBAs, basically never exploit the functionality that's there because it's actually turns out it's kind of difficult. So, and it's not difficult because it's technically difficult, but it's difficult because it's all friction, right? So, Postgres has a large list of different things that we can potentially fall back on. pghba.conf, right? Can we talk to this particular database, yes or no? And that downscopes you just to the database level itself. And if you're running something that's big in production, there's probably only one database there, so it doesn't provide you with a huge amount of value, but it's something, right? And that's managed through file management, right? It's not something that you can do typically dynamically. Then we have roles on top of that, and you can scope things a little bit further. You can have DCL and control who accesses what table based off of username. You can potentially use row-level security if you wanted to, but somebody needs to administrate that. That doesn't come for free, right? A lot of times, some of us will go in and implement or execute those grant statements for a particular team as a two-man role, so that I, the DBA, am going to be the person in charge of making sure that the application is not misbehaving, right? But that again, that's coordination between two different organizations. And it's done statically. It's done at human time, not at machine time, right? So, okay, fine. Maybe somebody's got a solution to this. Maybe we can use configuration management, right? Either for permissions or for the keys. You centrally manage, fine, that's not necessarily the bad thing, but it's eventually consistent. Maybe like there's different developers that have different checked out versions of configuration management scripts, and it hasn't converged yet because somebody's working on stuff in branches, whatever, that's one thing. There's not typically access control around your configuration management. Like most of the time, your ops team has complete write access to the configuration management repo, so you don't get a whole lot there. There's very little auditing typically in the way of who ran the configuration management once you have done something. And what do you do for revocation? Once there's been a change, how do you know who had access to something so that you can potentially revoke it? And these are all problems that are kind of come from configuration management. So how do applications get secrets? You communicate them to somebody and you say, hey, I really want you to have this username www.user, and here's your password, and that's how that gets done, right? That's not necessarily ideal. Once I give it to you, how does a person manage it? Like, Do you throw it in a 1Password? Do you throw it into GitHub somehow? How do you update these secrets? One of my favorite problems to hear organizations talk about, and I'm saying this sarcastically, is, hey, I've got to go and roll usernames and passwords, once every 18 months or 3 months or whatever your password rotation policy is for like 1,000 applications, right? Like it's daunting as a problem goes. Again, revocation. So we can use Postgres potentially for doing this. And I have done this in prior lives where I've written password management systems in Postgres, but Postgres is not necessarily designed for this. So there's many good things about Postgres. I would say that this is a little bit dubious. You could potentially use PG Crypto and get a lot of these attributes, but it's not custom built, special purpose built for this. So what if we took these requirements and we tried to make something that was centralized, right? If you have the concept of secret sprawl, where you have usernames and passwords distributed in thousands of different application property files and source code, that's a problem. You want to actually take all of that complexity that you've now distributed across the organization, and you want to have it in a very small, focused place, because then you can control it, right? You can actually see what's kind of going in and out of this environment. Right now, we have static secrets as kind of the common paradigm, right? And this is what the talk's about, is how do we do dynamic secrets? So static secrets are www-user, password, 123, and we distribute that to each of the individual teams. This is basically what the database world and most everything has been kind of built upon for the last 20-something years. So if we also assume that, from a perceived versus real security threat perspective, that the boogeyman isn't going to come and steal our secrets off of a box that is running a process and is going to somehow take the passwords out of RAM. We're going to just make that assumption. We're going to scope the threat model to being a running process is something that we trust. Disk we're not going to trust. The network we're not going to trust. But when we go back and reevaluate these requirements, we can say pretty confidently that a running process and the memory that's in RAM there is trusted. Nothing else is, though. Right? We're willing to make that compromise because from a real versus perceived threats perspective, if somebody goes and does a memory dump of a running process in RAM, they've either got root on the box or they are the NSA and they've somehow done something to go in and cipher off all of the RAM to go in and deal with in some other sophisticated capacity, right? That's the extent of what we need to kind of think to potentially deal with if we make the assumption that a running process and what's in RAM is trusted. So, looking at kind of the requirements, if we assume that what's coming off disk is always opaque data, and it's trusted because we can checksum it, and we can authenticate the ciphered blocks coming back up, then we can potentially move forward with opaque storage, okay? Or move forward with treating opaque storage as opaque, more quickly. And then, let's see. I'm going to skip that, and we can get to availability. So if you have this central storage for passwords where you're going to be getting usernames and passwords potentially dynamically, you also want this thing to be highly available. So we need to build that into the initial set of requirements because you don't want to be locked out of your business because the thing that's handing out usernames and passwords is potentially went down. So what we really kind of want is we want something that looks like a bank, right? Something that's convenient like drive-thru and built like a tank. So no conflicting requirements there. So going back to kind of like where we're sitting here is like, that's what the purpose of Vault is here, is your application can, via automation and through APIs, talk to Vault. And similarly, once you're in a production environment, you can have things talk to Vault to go and pull dynamic credentials. So how do we do this? What does this look like? So in order to generate dynamic secrets and do so in a trusted way, this is the kind of like a logical diagram of the structure of Vault, the process, and the way that it interacts with the world. So what we see here is we have this network service that speaks HTTPS, and it talks to storage on the back end. The thing that we trust is this, what we call the barrier, this running process in the middle. It speaks HTTP out the front. It talks to encrypted data at rest. The data coming out of the back can actually use Postgres as a backing store if you wanted to. I wouldn't recommend it. I love and adore Postgres, but I wouldn't actually recommend it because the failover time for Postgres versus something like Consul is the difference between milliseconds versus whole seconds or minutes. But I'm not going to get into kind of like what each one of these things do, but there are a couple of terms that I do need to define that are important here. So you have the storage backend. The storage backend is where you store your ciphered text so that Vault can treat it as opaque data. Okay? Vault takes a secret, encrypts it, writes it out. There's many different places where Vault can write this out. Consul is preferred. Postgres is one. There is file. File is not HA. Storage backend. There is the secret backend. So Vault is going to talk to Postgres. Postgres is a secret backend. That means that Vault, with the way that this is wired up, that Vault can go and create a dynamic credential based off of the secret providers that are configured. So Amazon is a secret backend. Cassandra, MySQL, Postgres, there's a bunch of different secret backends. All a secret backend is it means that Vault is able to go and generate a dynamic credential from a secret backend. So anything that has an API key, a username and password, SSL key, can use, if it's supported, is a type of secret backend. So the PKI one is particularly interesting because managing SSL certs is a huge pain in the ass if you've ever had to do that at any real scale, especially if you need to rotate them on a regular basis or you want to have short-lived certs, like 30 days or 15 seconds. It's really, really hard to deal with PKIs. But there is a secret PKI backend, and this is something I will draw our attention to, but we're not going to cover in huge detail here. But Vault will generate signed certs from a supported CA. So then auth backend. Auth backend means if I'm going to go and request a credential, I need to tell Vault that I am a legitimate person somehow, right? And if I am authenticating with Vault as a user, I'm going to present, let's say, username and password, because that's what I'm going to keep in my head, or I'm going to log in using GitHub as a backend or some OAuth provider. That's my way of getting an initial secret. So as a human, there's also machine's ability to go in and request an initial secret, and that can be done through a seeded token or some other, there's many different ways of potentially doing with that. But again, auth backend, there's machine-oriented secret backend, or auth backends, and operator human-oriented backends. So you use these secret backends, you get a token back. This token is what you use to authenticate yourself with Vault. Think of it exactly like you would a session cookie inside of a browser. It's a large, high entropy token that you can use to go in and make requests against Vault, and you have privileges attached to that token. So then secrets, anything you don't want to have be public. I don't care what it is, you don't want it to be public, that's a secret. Username and password, that's a secret. You can potentially use the transit backend to encrypt data, like PII type data, if that's a type of secret. And then you have the Vault server. So there's a client-server model in Vault. You have clients that talk in the ether over HTTP to the Vault server itself. The Vault server is what enforces everything. It does your ACLs. It generates new credentials. Yeah. And so that's kind of the gist of what goes into the Vault process itself. I've moved reasonably quickly. I'm going to pause for half a second. Are there questions so far? Are we good? This is a small enough room that I can pause and ask. All right. All right, so what does it mean to actually use Vault? So, because as administrators, we actually want to be able to deploy some of this stuff and make use of the benefits of having dynamic credentials. So, in order to prevent what I call the conspiracy of one, where a single rogue operator can run away with your encrypted data, we seed the initial encryption key using Shamir, which means that we take the original secret and we give it to multiple people. And the only way that you can go and generate the decrypt key to go and decrypt the secrets that you have is you have to have multiple key shares present in order to unseal Vault. This is a really important part of the threat model, which means that individual people it takes multiple people to come together in order to unlock Vault. This is a disruptive event if the Vault ever goes into a situation where it has been restarted, right? So, because we don't want to be in a position where we trust individuals, right? I mean, we do, but we want to limit it so that it takes like 3 of 9 people, right? We give out 9 keys, and 3 of them physically have to be present to unlock it. So when you take all of the individual key shares, you generate you reconstitute the master key, which you use to decrypt the encryption key. That's important for key rotation purposes. And then you can move on with reading encrypted data off of disk. So that's what we have to do as people. What do we have to do to actually, what does it start to look like when we begin interacting with this? So the Vault tool is reasonably simple as crypto and security stuff goes, because we're talking about really rigid controls. It has a tendency to not be terribly friendly, or security in general has a tendency to, but this is pretty tame, I think. So in this case, we're initializing Vault with 5 keys, just like, that's really sensitive. In this case, we've got 5 keys, right? Key shares 5, threshold 2. Only 2 people need to be present in order to unseal Vault. And in this case, we're going to actually PGP encrypt the original secrets using my keybase, PGP information, and then I'm going to print it out so that I, the person who's originally setting up Vault, am never aware of what the original keys are. It helps solve that bootstrapping problem. It does support using non-PGP. You can have it print out the actual secrets themselves without using PGP as well. But it's a nice feature there. So, you set up Vault, you obtain a token, and I'm skipping through some of the details here. But what does it mean in the case of Postgres, right? So I've in theory set something up, and I want to grab this token so that I can move forward with having Vault generate a dynamic credential for me. What's the actual workflow and protocol exchange look like for an application using Vault? So the first thing is I, a user person, am going to authenticate to Vault and say, hey, I am Sean, here's my password. And assuming I gave the correct username and password, it's going to give me back a Vault token. It's that high entropy UUID looking thing. I take that token, and I can use that to go and request assets from Vault. In this case, I'm asking for a token to be created and that's attached to a policy. The response is another Vault token. This is hierarchical. So the response that I get back from Vault is another Vault token, but it's downscoped to whatever it was that I specified in my original request based off of my access privileges up here from the token that I got back in step 2. Okay. Now, I, the user, I'm going to use this token that I got back from Vault in step 4, and I'm going to pass that as the application to my application. As the user, I'm going to pass that to my application, and my application is going to use this downscoped token to, in this case, ask for a read credential on the application database, right, or whatever that policy is as configured in Vault. So what Vault does then, and this is where secret management becomes, or where Vault becomes interesting, is Vault will actually go and do my create role and my grants. It does that for me every time I request a new credential here. Okay, and that means that this username and password that's created down here is dynamic, and the policy that it comes with it, the grant statements, that's all managed on the Vault side of things. So managing your credentials there, or managing the DCL for a credential, is something that you have to program into Vault so that when you create this dynamic credential here, it's applied consistently. The response then is Vault will hand back, after it creates the credential, a dynamic set of Postgres credentials. Right? These are time-boxed. They're very limited in their duration, at max 30 days. There's a really interesting limit in Vault where at no point in time will Vault ever give you a credential that will live longer than 30 days. You are forced into rotating all credentials every 30 days. You can do it as fast as every once a second, not uncommon, 5, 10, 15, 30 seconds, once a day. But you cannot, it's in code, you cannot exceed 30 days. And then you, the application, will use the username and password that was dynamically generated to actually talk to Postgres or PG Bouncer. Okay. This means that every single server, physical box, application instance, you restart the process, doesn't matter. You're going to go through this kind of ping pong here, and you're going to end up with a new set of credentials. That's interesting because it means that this set of credentials here I can use to identify the physical server that made the request or the application reboot that the application instance. So if I restart app 1 for whatever reason, all the old credentials are going to go away. Right? There's a heartbeat that happens that isn't depicted here, where if app 1 or server 1 fails to heartbeat, Vault over here will revoke the tokens, revokes the credentials. Right? Your break glass procedure is you tell the Vault in server over here that some credential on either the physical server or a particular application has been compromised, whatever, and Vault will go and begin doing the inverse of the creates, which is your revokes and drop users. It also does a PG terminate backend. So this is very forceful, and it provides a discrete ending for when that secret is able to be used in your environment. So what's it look like? So in this case, we're going to create a database, app 1, create a schema, create a table, insert some data into it. Now we're going to, that's what we, oops. This is, our theoretical app here. We're going to tell Vault to mount Postgres as a backend. So one of the interesting things about security is that if the mental models don't map well to what people understand, then people have problems understanding the tool that they're using. So Vault uses a file system like, word just left me. Vault uses a file system mental model or way of kind of dealing with its infrastructure. So in this case, it's path-oriented. So you mount the Postgres backend. In this case, it mounts at the Postgres backend. And this help here comes dynamically from this particular backend. So you can actually interrogate your Vault server and figure out what backends are present and what you can do. And so you see here, when you mount the Postgres backend, there's actually this configuration stanza that comes back. And these are places inside of the Postgres backend here where you can write data into in order to configure things. This is how you configure Postgres. So you can think of this kind of like you would like the proc file system, where if you write something into /postgres/config/connection, you will write out the configuration string that Vault will use for configuring dynamic credentials in the future. So in this case, we're going to configure the connection, or we're going to get additional help on the connection here. We're going to see that one of the parameters there inside of the key is the database connection URL, max idle. There's a bunch of other parameters that are there. We're going to go and write out our config that's going to tell Vault, hey, go talk to this particular Postgres instance with these static credentials, because we do trust Vault, right? Not an unlimited threat model. We have downscoped it to just Vault and the process and its memory, right? So in this case, Vault is talking over loopback to this particular database instance, but you can put in whatever you need to here. Interesting and important note, SSL mode disable. Vault is written in Go. Go defaults to SSL mode equals strict, not preferred. So you will stub your toe on that for a while until you remember or figure it out. So in this case, we also say, I want to configure a secret so that all of the secrets, in this case, a username and password that's generated by Vault, has a max of a 1 hour, or I'm sorry, has a 1 hour lease by default, and you can renew that lease up to 24 hours. Okay, so in this case, what we're saying here is with the Postgres backend, you can renew as much as you want up to 24 hours, and then that renewal will begin to fail. So if, let's say you're renewing that secret once every 5 minutes because it's heart beating nice and aggressive, fine, I'm here, I'm still alive, I have my secret, you get to, 23 hours and 10 minutes or 5 minutes, whatever, the renewal will fail. Your credential's still valid until 24 hours, but it will begin to fail, and you have to go and get you have to re-authenticate with a new Vault token to get this dynamic credential back. Similarly, if you fail to heartbeat for that first hour, at the end of 1 hour, your secret's gone. Right? Username and password will be retired automatically, revoked. So we have this policy here, app1. What do? Well, we give it the SQL here. We write this into the Vault backend. In this case, we say create role, and there's interpolation that happens. So, and pardon the shell backquoting here, but create role, the name of the role. This is something that Vault will interpolate for you. Password similarly interpolated. And then you provide the DCL to scope this dynamic credential to this particular set of tables. Now when you go and ask for a credential from Vault, it will apply that for you uniformly. So if I go and read from Vault in this case, so the Vault command line you can use to interact. Like you don't have to go up into a PSQL session. You don't have to use a JSON API. You can just go into, you can use the command line to go and read a credential out. And so we get this lease back. We have a username and password. And these are all dynamically generated with the appropriate grants performed inside of Postgres. So I can see that if I read multiple times here, so this one came back, like if we look at it's BD0 for the first read, we do a second read here, the second one comes back as, oh, this is a copy from the previous page, sorry. So if I hit Postgres, you can see inside of the database, I can, there's this dynamic credential that exists. All of the policies have been applied here. This can be quite messy if you're into the aesthetics of looking at the actual privileges, there's a lot of churn. But let's see. So I change this one here. I can't tell if I'm going forwards and backwards. There you go. So there you go. This clicker's not working for me. So in this case, I have access, and I can go and select my row out of the database. So similarly, if I need to go and revoke that token, let me give this one more shot. If I need to revoke that token, I go and take the lease ID here, and I pass that to the backend. So these are two separate secrets. The username itself is secret. The password itself is secret. This lease ID is a second piece of metadata information that I can use for future calls that won't disclose any other information. So in particularly hostile environments, this separate lease ID from username and password is particularly important. So I use that lease ID here, and I can revoke an existing credential. And so what that'll do in this case is it will it revoked just my one user. You can also do break glass. So in this case, you can say revoke everything at a particular mount point and all credentials that were attached to a particular policy that came from a particular mount point or policy inside of the path here, all of them will be revoked. So I now have the ability, if I need to go and force the entire rekeying of my infrastructure, right? I had something was compromised, whatever, I can go and blow it away. Right? If I have a new application version versus old application version, I now have a story. I have a strategy for dealing with this particular scenario. And I can do this all at machine time, right? Like this revocation happens instantly. It's doing a Postgres PG terminate backend in order to close things off. So you know that as soon as that's done and Vault has a chance to talk to Postgres, it will very thoroughly clean up after you. So in this case, I want to go and grab a couple of more credentials. And you can see this kind of chain of trust where a Vault token can get a different Vault token, can get a different Vault token. And every time you're doing this, you're down scoping to the whatever the lowest privilege possible. So in this case, I've got a token that I ask for. I can use that token to go and read something out of the credential. Great. And I can go and read multiple, and it gives me multiple things back. Pretty straightforward. Go look inside of the database and I can see, hey, I've got multiple credentials. They're both different. And I can go and revoke. And because both of these credentials here came from the same token, right? See this vault token FC2OF, FC2OF. I have 2 separate usernames and passwords. When I go and revoke that FC2OF, I revoked everything that came from that token. So internally, think of a big tree. And when I go and grab my, my FC token here, and I grab 2 additional users that came from this, then if I revoke my FC user here, everything that came from that, was attached to that vault token also gets revoked. This is how we handle compromised machines, right? Vault tokens you can seed on servers. When you seed that on a server, and then the application spins up and you have like, we use that initial seed for like, 3 different applications, let's say, then I can potentially do break glass, and I can say, hey, the seed that went, the initial vault token that went to server 1, 2, 3 over here, turns out that it had both a Java app and a PHP process, and like one of the 2 got rooted, whatever, and I need to go break glass and shut everything down. You can do that. So I mentioned API up front. Everything through Vault here. The command line, it's nice. It's talking through the Vault API. It uses the Vault token and then makes an HTTPS request. Whoa. Sorry, it's super touchy. There we go. OK, so if you want to integrate Vault into other types of systems, there is a full and very rich API here. The command line just uses the API. There's no second, magic squirrel thing that's happening where it's talking to the raw data or like none of that. Everything goes through the front door. So in this case, you can see, and it should be reasonably legible as APIs go. In this case, where we pass in the Vault token, we're asking for the app1 creds. JQ just to pretty print the output. You can see you get username and password. And this is like one of the things that's exposed through the API that's not through the command line is, was this response renewable? Right? Remember how I said you can create a response that has 1 hour versus up to a max life of 24? Well, if I go and hit this renew for this particular lease ID, that'll work up until the end of, let's say hour 23, and then all of a sudden it'll say renewable false. And that's your signal to the application that, hey, this potential credential is going to go away here soon. And this lease duration here will start ticking down. So that's great from an API perspective. There's other things that can consume Vault in order to dynamically generate usernames and passwords. You don't have to be a programmer, and you don't have to integrate a shell script in order to make this happen. And this is an important thing. Consul-template as a way of consuming secrets is actually a really nice way of going about it because you don't have to do anything. Right? All of this feature-rich functionality in terms of doing the heartbeating for you, writing out a file, that's what consul-template will do. So in this case, you use it as a process manager. So you consul-template, pass in config, blah, 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 a handful of other parameters, / my application, whatever. And then what will happen is consul-template will talk to Vault, begin heartbeating, saying, this child process is here, so it handles all your heartbeats and renewals for you. It renders out a file, so like pgpass, properties file, something of that nature, and then it fork execs your process as a child process. And if that process dies, consul-template will reap it and clean up the secrets for you because it will immediately, if possible, it will notify and say clean up immediately. If not possible, because in the event of, let's say, a kill 9, then the secret will time out and it will clean up after itself as well. And this provides a really nice way of integrating without basically zero touch. Right? You can take an existing application, like where you have external username and password. You can use this to start up a process. And that means that the username and password for your database application here will be consistent for every single connection. You didn't have to do anything. It does mean that because of the max 30-day secret lifetime, you're never going to have a process that's running for more than 30 days. That, from a policy perspective, is probably a good thing. But that's the only thing that you have to worry about, really, when using consul-template in order to write out some config file before rendering or starting a process. It's basically zero touch. There's another program that does an almost identical thing, and these two are about ready to be merged together. So heads up if you see env console go away. It does exactly the same thing as consul-template, except it sets environment variables for you. right? So if you wanted to have an environment variable that said like, app1 username, then your application could potentially read from that because env console, just like consul-template, will start your process and it will set environment variables before it starts the process. This one is something that I highly recommend if you're keeping an eye on because it's getting closer to having raw TCP support. So if you do HA Postgres and you want to be able to route to the nearest instance, look at Fabio. Right now it's HTTP only, but recently they added TCP SNI support. So if you wanted to find a particular server name based off of the SSL cert and the request information there, you can actually do that. And this one's a neat out-of-the-box kind of integration. But Fabio also will do cert rotation for you. So that's an interesting one. So last bit here, initial secret. Right? Back in this diagram here, you had to go and authenticate. You did that initial, in this case, in the example here, I said did username and password authentication in order to get that first vault token back. Well, that's nice, but it's a pain in the ass. And it's kind of been a pain in the ass for a while. This is what we call, it's the initial secret problem. Yeah. So coming very soon, like in the next day or two, the initial bootstrapping of that first secret is something that we've handled in the integration in Nomad, so that if you start your process with Nomad, Nomad will provide you with that initial vault token that's scoped to your application. So as an application, you only have to deal with from 3 on down because 1 and 2 is handled, and even before that, handled by Nomad. The more formal name of this is called secure introduction, and it's an ugly, ugly, ugly problem. Questions? I deliberately moved through a lot. Let's go from left to right, or my left to your right.
So does Vault ever change its own credentials when it's talking to the database?
No, those are static. We call those root credentials because they're elevated privileges that give them create user. The important thing about that is the role that you give Vault for creating new roles can also be downscoped to just something that has create user privileges. Right? So, yeah. Josh?
Do you have any examples of what this would look like in application code in terms of the connection credentials, et cetera? You mean different than just like using this literally like PQ username equals token? So it's going to be that.
It's literally these two things, yeah. Or probably, yeah. Like I think it's more common for it to be like in this case, like I authenticated using user pass. So it'd be user pass and then me and then the actual token. If you use an initial token, the username is a little bit different here because I use token authentication, but what you use in your application is, this value plus this value as the password. Go ahead.
Does the root token have to be rolled, like on that 30-day max, or does root token stay the same?
Root token is the one exception. So root tokens are God tokens. Effectively, they can do whatever. And as a result, they also have an infinite life. So the root tokens are something to be guarded. You should not be giving out root tokens to anything. Root tokens you use to go in and set up initial, so like big hierarchy of trust. That root token is way at the top of that chain of trust. And that's what you use as a Vault administrator to create that first policy, for instance. Right? You can use that initial root token to create other root tokens. You want to keep that list of root tokens very, very small. Good.
So is there a vault agent running on the same node as the Postgres, or it's actually?
It's doing a network call. This is, in this case, Vault is making a libpq call to Postgres. So when I said secret backend, back up at top, Postgres, MySQL, Amazon, AWS, whatever. Although any kind of secret backend, Vault is doing that remotely. In the case of, for instance, AWS, we obviously don't have access to poke behind. We just make an API call. We do the same thing for any type of secret backend. So no agent right now. there is discussion about having agents in the future on if you wanted to have one. There's some value add from doing that.
So I have the same question. So do you have any example like how the policy looks like?
How does what?
How the policy looks like?
Yeah. In this case, this is what the SQL policy looks like. Like, that's it. And so in this particular example, I'm using alter group to add my dynamic username to an existing username. And this particular strategy actually is one that I would recommend as opposed to using something like this. Right? You want to, because then as a database administrator, I have a static username and password, and I manage it on my time. Yeah. What do you mean? Like, you can do whatever you want between that, these two double quotes. I don't care if you're calling functions or doing, like, it really is arbitrary SQL that's passed to Go's libpq backend. So whatever you want.
I mean, like, it's not only specific to Postgres, but like say for other systems.
Yeah, so in the case of the Postgres backend, the secret backend here expects an SQL attribute to be written to that particular path. For other backends, for instance, I think it's the AWS backend, you would set like secret key or a secret access key as one of the parameters. There's an actual schema for each backend provider so that, you know, MySQL has its own set of things, Postgres has its own set of things. It varies based off of backend. But the generic interface is, I don't have to, like, as a consumer vault, all I have to know is go to Postgres roles app1 and request a credential. Implementation detail, it's all handled by Vault, right, as a consumer.
You've had several thousand databases.
Yeah. Yes.
Big collection of applications.
Yes.
And occasionally hardware fell over and you moved stuff around.
Yes.
How are you going to manage all the connection strings that are buried in this?
Yes. So, a couple things. I didn't cover it in this example here, but when you mount the Postgres backend here, you can mount a dedicated Postgres backend to a different prefix. So the default, if you don't specify a mount point, is to use a mount point that is the same name as the mount point that you're loading. And if that was confusing, it's much easier. The default mount point path is Postgres because the mount is Postgres. The mount type is Postgres. What you would normally do is you would have a Vault instance with DB1, DB2, DB3, whatever cluster timeline as dedicated mount points on the back end. Does that make sense? Or did that answer your question?
So I guess the thing, if I have maybe 20 applications and I really kind of get the same permissions across all these 1,000 databases, I'm going to replicate the whole configuration 1,000 times?
You don't have to replicate any. I'm sorry, go ahead.
So I have 1,000 applications.
Yep.
1,000 databases and 20 applications.
Yep.
That might have roles. But each of the applications, again, in all 1,000 databases, there's shards, basically.
Yep.
So
You would need to. You want to have the same username and password for an application to be able to talk to 1,000 backends?
yes. Or I want to say that this running instance of an application can connect to each of the thousands.
Yes. I actually need to think about that. Can I get back to you on that one? That's an interesting use case and one that we haven't had to deal with quite yet. But I'm not aware of it. I know that I'm pretty sure other people have.
The case I'm using, they're using kind of a workflow engine.
Mm-hmm. What you're saying, like, just tick something off, and I need to think about it. Josh, you were on. Okay, sorry. Next.
You mentioned HA.
Yeah.
I didn't see it in the slides.
Yes, I didn't deliberately do that, but more just out of time. Let me go back to an architecture diagram. So storage backend here. So there's two things that are important to know. The storage backends can be HA or non-HA. File is non-HA, as an example. It is resident to a physical server, which means that the process is also in a non-HA mode. If you're using something like console, which is HA because you have 3 or 5 or however many backend servers, you have an HA storage backend which enables HA process mode. Now what that means is
especially in the case of console, there's some, it's not magic, but like, just out of the box, it just works and does the right thing, kind of goodies there. When you start up multiple Vault processes on different servers that you trust, that are a part of your threat model, console does not have to be a part of your threat model, but these Vault servers do, right? Their memory, their process space, everything, that's needs to be trusted. Vault will talk to console in order to establish leadership across the Vault processes, so that if one of the Vault processes, Vault 1, 2, 3, let's say, if let's say Vault 1, which happened to be your leader, died, then Vault 2 or 3, which are in a follower state, will promote themselves to a leader state automatically. And it's done using an interesting set of crypto tricks so that it's not actually coordinating that leadership using any of console's primitives. But there's other things, yeah, so from an HA perspective, let's say you have like 3 or 5 or 10 Vault processes running with like, 3 or 5 console servers on the back end. And the Vault needs to be unlocked on, I need to think that this has been changed. I think you need to unlock Vault on each one of the individual boxes. And then once you do that, leadership happens automatically. From a service discovery and registration perspective, it's particularly nice using console as a backend because you can just go to vault.service.console and it will always take you to an available up instance. There is some federation for throughput and other things like that is supported, but now we're getting way into kind of the weeds of some of that. But yeah, it's there. So the gist of it is, though, is HA storage backend enables HA in the sense that you have multiple processes that are able to read and process secrets on the back end. And if you talk to a follower, there's some behind-the-scenes relaying of requests so that like everything just like looks magic. It just works. Yep, it does the right thing. Yep. In an old version, it would send a 302 out of the API client to pass you to the current leader. In the new code, it actually will relay the request between the Vault servers for you so that your connection here doesn't ever get the 302. It's basically magic. Go ahead.
And to just comment on that as well, like I have a PR in for Vault. It's really early stages, but if you don't want to use console as your storage backend, then you can have Vault just communicate leader election stuff natively. But that's probably a while out.
Yep. Other questions?
But there would be nothing to stop you from throwing HA proxy in front of all your Vaults.
Yeah. Yeah, you could do that. That's, if you're willing to accept that as part of your threat model on this side of things, go for it. Other questions? Cool. With that, I think we're good. Thank you.